Hello, this is Dr. Dan. In this video, I'm going to use Excel as a tool to help you with data screening, cleaning, coding, organizing, and so on. So that way the data is ready to download into SPSS for analysis. Some of you may know that SPSS is also a great tool to do this. However, the process is a bit different, and many of you are much more familiar with using Excel for these stages and steps, procedures, what have you, rather than SPSS. So I thought this video might be helpful for you. I'm one of those that I like to use both, depending what I'm doing, and I really do like Excel for a number of reasons. So I just thought this video might be helpful. So what you have in front of you is data that we downloaded for a student's dissertation research project. We downloaded the data, and due to the way that we had it set up in the software where we collected the survey data, we sort of created a few problems for ourselves, including, rather than, as an example, assigning a value to, let's say, each age, or assigning a value to race, for instance, we did not do that. So there's a feature in the software that automatically assigned a value. And so when you look at it here, these numbers are rather arbitrary. We don't necessarily know what some of these numbers mean. So that was one of the problems that we had, and some other things. So let's go ahead and begin here, and that way you can see how much work has to be spent with really looking closely at data, whether you use SPSS or Excel or another program. It's so very important to really effectively screen your data before you actually begin your analysis. Otherwise, you may be conducting an analysis on data that's unreliable, not valid, and so on. All right, so what do we have here? So we downloaded the data. You get this information, and one of the first things that stands out to me is these columns over here that separate race. So each one of these values, 1, 2, 3, 4, 5, 6, applies to a certain race. So just to make things easy for you, what I did is I applied all of those to one column here. Okay, so that's the first thing that we did to organize this. So now it's in one column. We're better prepared to download that to SPSS. Once we do download it to SPSS, at that point then we can in turn make some sense out of these numbers. So in other words, what does 1, 2, 3 mean, and so on. So in this example, 3 means African American. So within SPSS, we can assign meaning to those values. But if we would have just downloaded this to SPSS, this might have been a little bit messy. We would have had to do some more work. So here, again, in turn, we put it in one column. That's something that was rather simple. Here, we have another issue where age has some values, and these are not ages. They're not 1 year old or 2. 1 means something. So we had to go back to the survey. You look and see what we did, and basically we began age with age 18. So they had a drop-down box. They were able to choose an age. There's no value per se, like there's no value to that age. We didn't download the actual age. Instead, when this downloaded, which there's different ways of doing it, but just bear with me here. I'm just trying to show you how Excel can be very useful. So again, 1 means 18. Okay, so we found out what that value means. 2 means 19, and so on. So we're going to have to do something with this as well. We don't necessarily just want to download this in Excel, or excuse me, in the SPSS. Again, gender, same thing. These values mean something, but they're already pretty well organized. Now, I would say much more importantly is this information here. What does this all mean? How is it scored? And so on. So what we had to do is a significant amount of work to see how these were scored, what survey they belong to, or should say what measure. Because within the survey we had demographics, as I just pointed out. We also had 2 measures within the survey. And within those measures, some were reverse scored. So if we would have just downloaded this and began our analysis, we would have had some really unreliable information. So let's go ahead, and I'm going to skip now to the next screen where we've done some of the screening and cleaned up some information here. What we've done here is now, to help us better understand what we're looking at, I went ahead and created some additional rows and columns and so on, basically just to help us understand it. Because if you're just looking at those numbers, even if you're very familiar with what you're measuring, they may be confusing, or simply put, you may end up making some mistakes. So we want to have very clear understanding what this information is and what needs to be done with it. So gender, age, race, education, employment, and marital status, all that is nicely cleaned up and organized. We will make sense of what those values mean, again, once we download the SPSS. That's fairly easy within SPSS to assign meaning to those values. 2 means female, 1 means male, and so on. And again, we're not here to argue that it should be 0 and 1 and so on, which is a story for another day, but rather we just will assign meaning to those values, and that'll be done within SPSS. So here, what's more important now for this part of the discussion is identifying which column, so in other words, which question, a question pertains to each column, question in the survey. So in other words, in this column here, this is really too little chance for promotion on my job. Okay, so they were asked a question and responded to it using a Likert scale. However, for this particular column here, here, and so on, they were reverse coded. And you can see I identified in this row which ones were reverse coded. So what we had to do, or reverse scored. So what we wanted to do here is we need to flip-flop these scores. We know in this case that it is a 6-point Likert scale that we had to use based on the measure. So what we did here is actually create a formula within Excel. That formula is right up here. So that way, if the score in this particular column right here, as an example, was a 2, it needs to be actually a 5. And then within, if you're good at Excel, you can see over here, that's this part of the formula here. If it's a 5, if it's a 2, it means a 5. If it's a 1, a 6, a 3, a 4, a 4, a 3, and so on. So we created that formula after creating another column, because back over here, again, this is all the raw data. So we had to do some work here. Not only mark which item is which, so in other words, this is question 1, question 2, question 3, question 4, which subscale applied to each question, because in this particular measure there was 9 subscales, and then which ones were reverse coded. So that way now we can go ahead and get the proper scores applied to those that are reverse scored. So we created that formula, went ahead, and Excel is great where you can just simply go like this, and you can go ahead and you can copy that formula to all of these other cells, flip-flops them, so that way later on we can finally use these scores. We did run into some little internal errors that if we didn't catch would have been fairly problematic, and I'll talk about that in a moment here. But you want to always be double checking all your work. And I say double checking as just a phrase here, but I mean 3, 4, 5 times sometimes. Just keep checking to make sure you didn't make mistakes as you went along, because as you're working with data, very simple mistakes can dramatically change the results of your study. So we want to double check everything. That's kind of a lesson to learn here. All right, so we went and did that. We copied over the formula, went over here, copied the formula. Excel is great with understanding internally that now this applies to column K rather than H. Went and copied those and so on. So we went all the way along here. You can see for all of these that needed to be reverse scored, wherever there's an R, it needs to be reverse scored. And then finally we end up over here, which this, if you recall, this particular row was question number, item number, and the subscale. And here we can see that only 1 was reverse scored over here. So we only had to do that 1 additional column, and this is for, again, this is a second measure that we're using. And then finally what I added over here, just to help us make some sense of this information, is we have these various subscales. Here's the 2 different measures, and then an abbreviation what each of these means. Again, we know as the researchers what these mean, and within SPSS we can further clarify what these mean. Pay, promotion, supervision, and so on, benefits. And then down over here, I also added, just to help us as well as perhaps others that might look at this, again, what those codes mean. Okay? So I provided that here. And then including, I want to step further, showing that higher scores mean higher levels of job satisfaction. And then for the work-life balance scale over here, it's a little bit more complicated, where higher scores on these two mean lower work-life balance, whereas this particular scale, higher scores mean higher work-life balance. There's a lot of information to take in. So there again, if we did not have this clearly explained up here, then it might get a bit confusing. Or if you are a person, let's say maybe you're a student and this is your first research project, you may not necessarily understand what all of this means. So therefore, going through this process will help you understand it, because you have to double check how everything's scored. You have to double check what the various scores mean and so on. So it's a very good way of learning the details of the measures you're using, how they're scored, and how everything should be organized. Okay, so now let's go ahead and we'll go to the third tab here I created for you. This is what it looks like now after we've recoded everything. So actually we did the reverse scoring, we did our coding here, and you can see everything is nicely cleaned up. I kept these rows in here still so we can understand the information and do something extra. So what that is these item numbers, again, they're actually questions on the scale. So question 1 applies to subscale 1, and here are the responses that the participants gave. So what we've done here is we went ahead, created formulas so we could average out the scores for each of these subscales. So just for ease, because it's on the same screen here, let's look at the WIPL. 2.57 is the average, and that includes the average of these items right here. We know these apply to subscale 1 because the information's right here, and we know these apply, so we went and averaged those out, and there's the value right over there. So we created formulas for every single item within our survey that applied to each of these subscales. I mentioned before that some of this can be a little bit problematic, so let me explain what I meant there. One of the perhaps challenges with Excel is if you have a formula in here, then it may misread the information. So what we had to do is, if you look up here in this little area here, you can see they're all values now. There's no formulas within here. So what we had to do is actually change. So let me show you an example. You can see there's a formula here, whereas now, there's no formula in there. So we had to change all those formulas to values. Okay, so that it sounds kind of simple right now. The process, once I actually sort of reminded myself how to do that, it's actually rather kind of easy process, but it's very important, because there again, we double checked our work manually and found that 2.75, we had a different value in here. It was not the average of these values right over here. So we had to do something and figure out why that was happening. And once we figured it out, then we realized, oh yeah, that's what we need to do. We need to change those formulas to actual values. The point behind my conversation here is that, again, you need to double check all your work. All right, so what we have here now, everything's cleaned up. We have all of these calculations completed, because these are the ones that we're going to use for our correlational analysis. The last thing we want to do is get rid of all these extra rows and columns and things here, so that way it's really a nice transition from Excel to SPSS. And that's what I've done here in this final table. So in this particular, or I should say spreadsheet, in this spreadsheet, everything is nicely cleaned up. All of those columns and rows that we don't need are gone. We understand what all of these things mean. If you forget, we go back to the coded data tab over here and we can see what everything means. And so now we're able to download this into SPSS. Once again, to emphasize that SPSS, you can use it to do what we have done here in different ways. Perhaps in some ways it's much easier, and in other ways it may be a bit more complicated, just depending on your level of knowledge and ability using SPSS. Some of us know Excel very well, and so we may find that Excel is easier. Both are effective ways. Again, some have advantages to the other, but I wanted to create a video here for you just to show you what we can do with Excel in order to clean up our data so that way it's ready for analysis. Thank you very much. This is Dr. Dan, and I wish you a very happy and blessed day.